functions and relations. So up until now, we have been dealing with usually only one variable. For the next 4 units, we are going to be dealing with 2 variables. 2 things that can change. All right? So we'll start with some background as we always do. These 3 words are important in that I'm going to be using them all the time in this unit. So you need to know what they all mean. A set is any amount of data. Data is just information. So, what is the amount, what is the data for coffee cups in my hand right now? 1. So the set of coffee cups in my hand right now is 1. Everybody understand? You can see I have a coffee cup in my hand. Therefore, you have data that shows I have a coffee cup in my hand. You can count it. There is 1 of them. Everybody cool? Now, how many coffee cups are in my hand? 2. It is still a single set of coffee cups. Does everybody understand? All right. But now there are 2 of them in my hand. That is what an element is. An element is a single piece of data from a set. Now, here's something that most people don't know. I'm going to teach you guys some English here. Data is plural. The coffee cups in my hand are data, or if you're American, data. Okay? This coffee cup is a single piece of data, and the proper word for that is datum. This coffee cup is a datum. But nobody uses that word, so I won't either. But that's the proper word for it. So, the set was coffee cups. Of which I had 3 in my hand, because I'm going to grab my Christmassy one too. So I have my travel mug, my Christmas one, and my awesome teacher mug. That's the set. 3 coffee cups. Right? In that set of 3 coffee cups, there were 3 elements. My travel mug, my teacher mug, and my Christmas mug. Wait, I don't want to be culturally insensitive. My winter festival mug. Okay? Everybody understand? Now, a relation is any time you compare one set to another set. So, in my hand, this demonstrates actually 2 sets. What are the 2 sets that are being demonstrated right now? One of them's written on the board. It's the coffee cups, right? What is another piece of data for this set in my hand? Pardon me? No. That's part of the set of cups. I need another set before I have a relation. I have to compare the set of cups to another set. The other set is any amount of data. What else in my up in the sky here now can be counted? Zach is saying fingers. Or I want to compare two sets. If one of the sets is coffee cups, it has to be some sort of relation to the coffee cups. My hand. Does everybody understand? This illustrates a relationship between my hand. How many pieces of data are in the set of hands in the air right now? How many elements? There's one element in that set. How many elements are in the set of cups? 3 elements. What's the relation? One hand will hold 3 cups. Do you think I could get another cup into that hand? Do you think I could? Let's see. How many sets? How many sets? 2. What are the sets? Hands and mugs. How many elements in the mug set? 4. How many elements in the hand set? 1. Which of those elements? We'll stop there. All right, so everyone's cool with this? Okay? All right. Okay, let's see if we can apply this to another chart or another series of data. So, here I have a table, yes? Some people call it a graph, that's fine. Whatever you want to call it, I don't care. This graph is a relation because there are 2 sets on this graph. What are the 2 sets? Height is one set because in height I have some data. I got 6 heights of dog, correct? Okay. That is set 1. What is set 2? Type of dog. Everybody understand? Easy peasy. I'm counting 2 things, right? I got 2 sets. Is everybody with me? Okay. Now, for each of these dogs, they all have a height, correct? Are all of these the same dog? No. So that means my type of dog varies, doesn't it? Because I'm not measuring all the same type of dog. So if it varies, this must be represented in math with a variable. Because variables are things that change. Everyone agree? Okay. Does the height of the dogs change? Sure it does. So the height also varies. So the height also gets a variable. Does everybody understand? Now, can I use the same letter for both of them? No, I cannot, because they are different things, yes? All right, so good. You're aware I can't use the same letter. Now, we have a certain rule in math class that isn't always a rule, but it mostly is a rule. If you make a graph, what variable is usually on the horizontal line? Those are x's. What variable is usually on the vertical line? Those are y's. That's not always the case, but we're going to say that's 90% of the times true. Okay? Now, since these variables are in a relation, because we are comparing dog type to dog height, aren't we? This chart compares dog type to dog height. And we'll pause there for now. Okay. So, I am comparing dog type to dog height. So, what would you say is that comparison for this first column? What would you write for dog type? Hound. And what would you write for height? 60. X, Y. Just like when we're making a graph. What would this one be? I don't even want to say Chihuahua because they're not really a dog. Chihuahuas deserve to live only in a world whereby other dogs would eat them, because in nature a Chihuahua would never survive. But some people like them, so they're a thing. What's the height? Do any of you have a Chihuahua? A wiener dog is German, a Chihuahua is Mexican. So, no, seriously, they're very different dogs. Anyway, what was the height of the Chihuahua? Sure, we'll call it 11, no problem. What's next? Corgi. Those are the type of dogs the Queen has. They're a little hairy. A Corgi looks like this. You deserve to learn stuff in class. I don't mind teaching you stuff in class. Hey. Corgi. What the halibut? What is going on, you piece of crap? Corgi. Those are corgis. I'm not a big fan of them, but the Queen loves them. They're kind of like a wiener dog. They look a little like a regular dog, but they got short legs. The Queen loves corgis. Look at that rump on that one. Now, my personal favorite dog is, of course, that dog. That's my dog. He's a shepherd lab. His name is Cooper. But in actual fact, if I had an unlimited amount of money and I was willing to pay thousands of dollars for a dog like crazy people do, I would get a Pomsky. Because Pomskys are huskies crossed with Pomeranians. So you end up with little tiny huskies. But you could go wrong and get a husky-sized Pomeranian, which could possibly be one of the worst dogs ever made. Now, fun story. When I was a kid, my buddy had a dog, and that dog was an artificially created dog. The people who had the dogs helped the dogs to mate. And they had a Chihuahua daddy and a Labrador mummy. They took the Chihuahua's business, put it inside the Labrador to make a Labrador crossed with a Chihuahua. And they were very, very lucky because what they got was a Chihuahua-sized Labrador. But what if it had gone the other way? And they had ended up with a Labrador-sized Chihuahua. Yes, Chihuahuas are the worst. But what if you add that, but the size of a Labrador? I know, it would be horrible. Yeah, Chihuahuas are the worst. Although my sister has a min pin, it's pretty close to the worst. If I didn't love my sister, I already would have taken that dog to a ferry or something and practiced drop kicking off the edge of the ferry to see how far I could send the dog. Because, of course, it's a useless dog, because even if I kicked it off at the dock, it's so useless it couldn't even swim back to shore. My dog can swim for about 27 miles because he's an actual dog. Anyways, Then there is a lab. What would you say is the height on the lab? 45. Then there is a shepherd. What would you say is the height on the shepherd? 45. And then there's a Malamute, which is a giant dog. And what would you say its height is? 80. So, does everybody understand? I have two sets. Set 1, dog types. Set 2, dog heights. The relationship is each element in the one set relates to a height, an element in the other set. Is everybody good with the basics? Okay, this is a relation. Anytime you have some info and you pair it with some other info, you are making a relation. Good? All right, turn the page over. A function, new word. New piece of vocab. A function is a special type of relation whereby each element relates to a unique element in the other set. So, in a function, in a relation, you compare anything. In a function, every element in one set relates to only one element in the other set. Everybody cool? So, all functions are relations. But not all relations are functions. Okay? And I'm going to go back to the dogs and show you whether that's a relation or a function. I'll come back to this page in a sec. If you don't have it written down, don't worry. So, we know this is a relation because we're comparing two sets, right? Dog type, dog height. Once we're comparing them, we have a relation. Let's see if it's a function. Hound relates to 60. So I have one piece of data, it relates to one other piece of data. So if I'm only counting the hound, it's a function, correct? Add the Chihuahua. The Chihuahua is 11. Is it still a function? Yes, because one dog type equaled another dog height. What about when I add the Corgis? Still a function? Okay, what about when I add the Shepherd? Shepherd's 45, but so is that. Or the Lab and the Shepherd. So once we get to there, it's a function. Once we add these guys, it becomes a relation. Does everybody understand? I'm going to give you another way to make that decision in case you're having trouble with it. If I say the next word I'm going to say, tell me what you would relate to that word from this chart. Everybody good? Everybody ready? Hound. 60. Good. Okay. I'm going to do a second one. Ready? 80. Malamute. Great. Perfect. Corgi. Awesome. 45. No, you can only compare 1 to 1. So I said 45. What am I thinking? No. No, you only get one chance. What am I thinking? No. Everybody see now why it's a relation? You don't know which I am talking about. Everybody understand? That makes it a relation. If this bar was not there, then do I have a function? Yes, because every dog has a unique height. Everybody got it? Another way I like to remember it is this. Input versus output. If you want to know the height of the dog, I got to tell you the name of the dog, don't I? Right? If I say corgi, you know the height from looking at this chart, correct? Everybody agree? So in a function, each input equals one output. Is everyone cool? All right, let's do a couple of examples. Each month of the year relates to a number of days. So, what is set 1? What is the first set in that relationship? Month. Great. So we're going to say that month is input. Because when I give you a month, you can tell me the number of days in it, correct? What is set 2? Are the days. And that's the output. Does everyone agree? Okay. So what's the first month of the year? January. If I input January, how many days are in January? 31. One input, one output. Is it a function? Yes or no? Yes, because one input gives me a unique output. What's the second month of the year? February. How many days in February? 28. What if it's 2016? 29. One input of February, how many outputs? 2. So is it a relation or is it a function? That is a relation. Because at the input of February, I get 2 outputs. Is everybody cool? Everybody understands? And we could go on. What's the next month? What's its output? 31. So January and March got me 31. So if I say, I'm thinking of a month with 31 days, can you tell me what month I'm thinking of? You can't, can you? Because I might be thinking of January, I might be thinking of March, I might be thinking of May, I might be thinking of July, I might be thinking of August, I might be thinking of October, I might be thinking of December. You can't tell, right? The only one you know what I'm thinking of is if I say, what month has 28 days? What month has 29 days? You're actually wrong. Every month has 28 and 29 days. See what I did to you there, Avian? Ha! Just kidding. But you're right, right? The only one you know is February. Okay, let's go to the next one. Every name on my class list, I have a list in front of me, relates to a kid in the class. So what then is my first set? What did I see first? Your names or you? Your names, because I got a list. So my names is my input. When you guys all walked in here on the first day, the kid became my output. I called the name. I input a name. Who was first on the list? Avian Anderson. And then I looked up, and there he was. That was the output. Everybody cool? So, is it a function? Well, let's check. First name on the list, Avian Anderson. How many Avian Andersons are in the room? Right? Everybody agrees? Okay. Second name on the list, Prussia. I don't like saying her last name because she makes fun of me. Prussia A. How many Prussia A's are in the room? 1. Everybody cool? Loveline Bava. How many lovely Bhavas in the room? One. So is it a function or a relation? It's a function. Always? No. What if I go by last name? Is it a function? Gil. Which Gil am I thinking of? There's three. Which Gil am I thinking of? You have no idea. So it's a relation. Understand? What if I went by first name? No, it's still a relation. Why? To Sahils. Right? So if I go first name, last name, it's most likely a function. Almost always. Except in grade 11 in Abbotsford Senior, because there are two Jasreet K. Dillons. Two of them. And they were both in my class. One in the first semester and one in the second semester. And they were both in my homeroom, so I would have to give out their report cards. I would never know which one was which. Because normally you go by, like you guys have had the same kid in the class. If there's Matthew and Matthew, one is Matthew M and one is Matthew B, right? Doesn't work with Jasreet D and Jasreet D. Oh, I'll go by middle name. Jasreet K. Dillon. Jasreet K. One of you wears glasses. Nope, they both wear glasses. Huh? I had to go to student number. Do you know your student number? They didn't. So anyway, it's not always a function though, is it? But in our class, it is a function if we go by first and last name. But if I only go by last name, it's a relation. If I only go by first name, it's a relation. Does everybody understand function versus relation? Everybody feels they could do it? Awesome. Let's move on. A relation compares two things. I use the words input and output. I inputted name, Avian Anderson. I output that kid. Everyone agree? Yeah? Okay. Now, we have to make some more categorizing of those things. And they categorize into dependent and independent variable. Now, some of you should have heard this and know what this is. Some of you won't. What does the word dependent mean in English? You depend on something, right? Without that thing, you cannot be. All of you right now are dependent on your parents. They give you a house to live in. They put food on the table. Now, some of you may pay rent already. I doubt it, but some of you might. But you are still dependent on your parents to provide that house to pay them rent for. Everybody understand? So we all know what the word dependent means, correct? So the dependent variable must be the set that changes when the situation changes. It depends, I don't want to say, wait. Its value depends on something else. I like to abbreviate that as DV. The independent variable is obviously IV. Now, the independent variable is the set that stands alone. Okay, I like to remember it as the one that's the same for everybody. Okay, Now, let's look at my previous example that I have right here, names and kids. Which one of those would you say is independent, and which one would you say is dependent? So let's pretend Mr. Brach walks in here again. What is he going to see? Is he going to see a bunch of kids or a list of names? He's going to see a bunch of kids. What if Miss Bell walks in here? What's she going to see? Bunch of kids. What if Kobe Bryant walks in here? See a bunch of kids. What if you're getting my drift here, right? No matter who comes in that door, they see a bunch of kids. So which of those is the independent variable? The kids are independent. Because no matter who comes in the door, they can count the amount of kids in here. Right? Now, if I say a name, or if I'm given a list of names, those names depend on which kid it is. Right? Everybody understand? We're going to do a lot of examples of that. I just want to get that out there. Now, the domain is the set of values for the IV. So you guys said the independent variable in this room were the kids, right? So how many values would there be in the domain? How many kids are in the class? 27. How many kids are in the class? So what is our domain? 1 to 27. Because there's 27 kids in here. Does everybody understand? Right? So if I start at the front door, Sartaj would be kid 1. So I input kid 1, output. If I point at you, you give me your name. My input is kid 1, output Sartaj. Everybody understand? Next kid, Sale. Input, kid 2. Output, Sale. Everybody got it? The domain are the set of values. The independent variables, the kids. The domain is the actual value for each kid. The domain is 99% of the time graphed on the x-axis. Okay? The range is then the set of values for the DV. And that there would be 1 to 27 names. And it 99% of the time is graphed on the Y. Okay. The domain is usually where we get our input values, and the range are our output values. I'm sorry there's so much vocab here, ladies and gentlemen, but it's just the way it is. Is everybody cool? The independent variable is the whole group of things. The domain is each specific value in that group. The independent variable is the set. The domain is the elements of that set. So go back to the cups in my hand, right? What is the independent variable? Cups or hand? Hand, because all of you have a hand. The output was 4, because I could fit 4 cups in my hand. Everybody understand? Okay, let's try a few more examples, make sure you get it. Sandy's getting a job at Flying Wedge Pizza, which doesn't exist in Abbotsford anymore, which tells you how old my notes are. She's getting paid $9.50 an hour, which is not minimum wage anymore, which tells you how old my notes are. Her hours of work are related to her pay. We understand that, right? I'm going to shorten this up. I'm going to say her pay per day to make it easier. We understand that your work and your pay are related, yes? Okay. What are the independent variable and the dependent variable? Talk to your neighbor, see if you can figure it out. Which is which? Now, some of you already know this because you've done grade 10 already. Some of you won't, but you should be able to figure it out. Okay. Which is which? What is the independent variable? Jeshen. The hours are the independent variable. Why do you say that? I'm not saying you're right or wrong, but why do you say that? Right. Your pay depends upon the hours worked. Right now, are any of you in work right now? No. Are hours still passing for you? Yes. So you're still inputting hours, but you're not getting any pay output, are you? Okay? That is why that's IV and pay is DV. Now, I want the domain and range. Okay? I'm going to make a couple of changes here. Her manager only schedules her for full hours to a maximum of 8 hours a day. So what are the values she could have for her domain? What's the lowest amount she could work in a day? 0. Right? Then what values could she have? 1, 2, 3, 4, 5, 6, 7, 8. Because he'll only schedule her for full hours. Now, legally in BC, you have to be scheduled for at least 4 hours. But let's pretend that that law doesn't exist. Is everybody cool? Everybody understands why this is the domain and this is the independent variable. Everyone understands the difference, right? The domain is the actual values. So what then is the range? If she doesn't work at all, what's her output? 0. What if she works 1 hour? 950. What if she works 2 hours? 819. 3 hours? 2850. 4 hours? 37, and so on. Everybody understand? Everybody understand? Okay. Now, is it a function? So remember, in a function, every input gives you a unique output. Yes, it is a function. Why? Because every change in the input gives me a new and unique output. So one day she works 4 hours, she gets paid $37, $38 actually. The next day she works only 2 hours, so she gets paid $19. It's not possible to change this and not get a different number down here. Is everybody good? Excellent. What about number 4? What's different about number 4? How's it written? In numbers. There's no info. But what do we know in math when we write number, comma, number? That's X and Y. Which of those was input? X. Which of those was the independent variable? X. So, what then is my domain here? 1, 2, 3. Oh, wait, I've been doing domain in green, haven't I? My domain is 1, 2, 3, 4. What's my range? 3, 6, 9, 12. Check if it's a function. 1 takes me to what? 3. And only to 3, right? 2 takes me to what? 6. And only to 6. 3 to 9, 4 to 12. So this is a function or relation? Function. Okay. Y, same thing. Every input, one output. What about B? What are my domain values? No, domains are x's. 1, 0, and -1. Because this 0 is another repeat, same value. What are my outputs? I have 0, 1, and -1. When I input 1, what are my possible outputs? 1 goes only to 0, correct? So it's a function, yes? So far. What about 0? When I input 0, I get an output of 1, and I get an output of -1. Is that okay? No. That makes this a relation. Because at input 0, I got 2 outputs. Everybody understand? Everybody understand? So you guys do the last one. What's the domain? What's the range? What's the categorization? Relation or function? What's the domain? 2, 4, 6, 8. Who do we appreciate? Math, math, rah, rah, rah. You all love math. Don't say it that way. It's your favorite. If it wasn't your favorite, you wouldn't be giving up a month of your summer to do extra math. It's your favorite. La, 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 la. It's your favorite. You love math. You would rather do math than anything else in the world. Because if that wasn't true, you would be out having fun all summer. I can't hear you. I've already made up my mind. I'm Donald Trump. No amount of truth will change my mind. What's the range? 3, 5, 7, 9. Function or relation? Function. All right. What's different about D? It's points on a graph, right? But every point on a graph is made up of what? And 2 numbers. One is what? X, which is an independent variable, and one is Y, which is a dependent variable. So, at that input, at that domain value, what's the range value? So there's one output at that input, correct? What happened here? There's 2 outputs. Is this a domain? Is this a range? Is this a relation or a function? It is a relation. Hey, Tirath, why is this a relation? I don't know. Because I won't shut up and pay attention. Hey, pardon me? Nope. Jazzkarn, why is that a relation? I know you don't, because you weren't paying attention. That's why I'm picking on you. Okay? So now shut up and pay attention. Okay. Why is this a relation? Because at input -2, I got two outputs. There and there. And that's not allowed. Everybody cool? Now, look at the difference. When I had a list, I actually had to write it out, didn't I? But when I had a graph, I could just see that at that x value, I hit two y values, didn't I? That gives us what's called the vertical line test. The vertical line test only works on graphs. And it is this: a vertical line moving across the x-axis will touch the graph once at every x value. So, the vertical line would move that way along the x-axis, like this. If it only touches the line once, you have a function. If it touches the line more than once, you have a relation. Does everybody understand? All right. So let's look at this question. It's a little hard to see, so I'm going to make the dots a little bit bigger, and I'm going to make them red. So, is this a graph? Yes or no? Yeah, it's drawn out here. So let's check with a vertical line. If it's a function. Function or relation? Function, because I'm only hitting a red dot once. Function or relation? Function. Relation. So this is a relation. Why? Because at x equals -1, there's two outputs. Okay? Now, the next part is kind of difficult. You can see I've put it as its whole own section, domain and range. Okay? It's really easy to explain, but it's a little hard to understand. So, domain, not R, domain is all possible values for the IV. Now, 99 times out of 100, where is the IV? The x-axis or the y-axis? X-axis. So it's the x-axis 99% of the time. So let's check our x-axis. Is there a dot right there? Yep. Right there, right there, right there, right there, right there, and right there. What are the values for x? What are the possible values for x? -3, -2, -1, 0, 1, 2, 3. That is my domain. To write it properly, we would put squiggly brackets around it. The bracket that looks like this on your phone, that used to make the devil horns in the old emojis days, before phones made emojis for you. Okay? The range, I'm going to do in red. If the domain is all possible values for the IV, the range is all possible values for what? For the dv, which is the y-axis. Again, 99% of the time. What are my range values? Well, there's one there. 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 And there's one there. What are the range values? Squiggly bracket. -2, because you always put the lowest one first. -1, 0, 1, 2, 3. Now, what is strange? How many domain values do I have? 7. How many range values do I have? 6. But I have 1, 2, 3, 4, 5, 6, 7, 8, 9 points. Does everybody understand? The domain and the range values are only half of the point. The point has both. So we can have 9 points, but we don't have to have 9 values in both of them. Does everybody get it? Everybody get it? Okay. So, what's different about B compared to A? Is it still a graph? Yes. So, can we do the vertical line test to see if it's a function or relation? Sure I can. So I'm going to get out my vertical line, and I'm going to slide it along the graph. What is it? It's a function because that vertical line only hits the curve once, right? So it's definitely a function. Now, how does the domain and range differ between A and B? What's different about the two graphs? It's continuous, isn't it? Graph A only had single points, so we had to write a list. But in graph B, my x values, my domain, is all the x values, correct? So it starts right here, yes? What value is that? -3. Does it hit every number all the way along here? It does, doesn't it? It hits every decimal and every fraction, correct? Would it be possible to write commas? No, because that's an infinite amount of numbers, isn't it? So we write this differently. Our domain starts at -3, and it's got a dot there that's colored in, so it is less than or equal to -3. And then we're counting x's, and my x's hit a maximum of what? +3. So my x's are less than or equal to +3 because, again, the dot is colored in. Does everybody understand that? -3 is less than or equal to all my x's. So nothing can go lower than -3. But my x's are less than or equal to +3, so they can't get bigger than that. This is what we call set notation. And if we were going to write it out properly, it would look like this. X with a colon, and then a squiggly bracket, and then -3 less than or equal to x less than or equal to 3, squiggly bracket. But I don't care if you learn to write it that way. Everybody good? We also write it another way. -3, and we put a square bracket because it hits -3. And it goes up to +3, and we hit +3, so we put a square bracket. This is called interval notation. I don't care which one you use, but you have to be able to read them both. Can everybody read both of them? The edges are just the limits. Everybody cool? All right. Go on to C. What is different about C from B? There's 2 lines. Are they still graphed? So can we still use a vertical line test? Let's check. Vertical line. How often do I hit? Once. Then there's nothing. Then once. So is it a function? It's a function. Now we have to be very careful because now things change. Where does the domain live? Which axis? The x-axis, correct? So what is the lowest x value? Look closer. -30. Because each of these are worth 10, right? So my domain starts at -30. What kind of dot is that there? Is it colored in? It's closed dot right there. So it includes -30 because that's a closed dot. What is this dot? That's an open dot. So is -10 included? No. So write x less than with no equal sign -10. This because it's a closed dot. And this because it's an open dot. So our domain goes from there to there, correct? But what happens right here? It starts again with an open or a closed dot. Closed dot. So is it included? So it's 0 less than or equal to x. And it goes up to what? 30. Does it hit 30? So it's less than 30. Because there are 2 different sets, we put a U between them. And the U stands for union. Now, take this and write it in interval notation. Do we hit -30? So we put a square bracket, -30, comma. Do we hit -10? No. So we put a round bracket. And then we have a union. Do we hit 0? Yes. So what kind of bracket? Square, 0, comma. Do we hit 30? So what kind of bracket? Round. Everybody good? Okay, now you try that for the range. Where do we count range? The y or the x-axis? Just the y-axis. So what's our lowest value for y's? -20. Is it an open or a closed dot? Closed. So -20, and we actually hit it. So we have to have an equal sign. What are we counting? Y's or x's? Y's. And what do I go up to? 0. Do I hit 0? Yes or no? No. 0. So no equal sign. Does it start again? So I need a union. Where does it start? 10. Do I hit 10? No. What am I counting? Y's. Up to what? 30. Do I hit 30? So I put an equal sign. Now write that in interval notation. -20. What kind of bracket? Comma. To what? What kind of bracket? What kind? Round. Union. Do I hit 10? So what kind of bracket? Round. 10. Up to what? Do I hit 30? Square. Is everybody good? Okay. Let's look at the last one. Is it a graph? Yep, so we can check with a vertical line. Ah! Son of a... Ah! Fine. I'll just turn you off. Huh? Now who wins? How many times do I hit it? Once. Look closer. What is that open dot? Does it exist? So am I hitting it once or twice there? Only once. So this is still a function because of the open dot. So what's my domain? What's my lowest x value? -9? Absolutely right. Do I hit -9? Why do you know I missed -9? Open dot. So -9, what am I counting? X's. So let's start along the road. What happens right here? Does it start again right away? So I keep going. Then I get to here. Does it start again right away? So I keep going. And it ends there. So what's my domain? 6. Do I hit 6? That's my domain. What is it in interval notation? Round bracket, -9, comma, 6, square. What's my range? What do I count now, X's or Y's? Is there anything between 3 and the next one? So I can't color this in, can I? The next one's here. The next one's here. What are my only range values? Negative. 3, 6, 9. What's the interval notation there? It's a trick question. Is there an interval notation? No, because I can't be... It's not colored in. They're just single dots. So there is no section of the y-axis. Is everybody good? Everybody's good? All right, now I want to show you a couple of other things because as you know, that much white space isn't there for a reason. Everybody draw this graph. Just make an L. Draw this line from 0, 0, just up diagonally with an arrow. What does that arrow mean? Keeps going. For how long? Forever. In what direction? Up and to the right, correct? So, what is my domain? What is my lowest domain value? 0. Close dot, I hit 0, don't I? Greater than x. When will this graph end? Never. What's the number that's at never? Infinity. So I'm less than infinity. Will I ever equal infinity? No. Now, the reason I show you this is because that's what makes sense, correct? Right? In interval notation, that would be 0, infinity, round bracket, because we never get there, correct? But we know math guys are lazy when they write stuff out, don't we? Right? That's why math guys don't do 7 plus -4. They just write 7 minus 4. Right? We know math people are lazy. So when it's this type of situation, math people don't like to write it out this way. They write it this way. And I'm going to still use blue, but I'm going to use a different shade of blue. They write this as x is greater than or equal to 0, which means it's every single value bigger than 0. Does everybody see the difference? Okay, what is my range value? Where does it start? 0, less than or equal to y, which is less than infinity, right? And then I would do 0, infinity for range, correct? But I'll keep using a shade of red. I'll go to pink. What would this be as, what would this be as a math guy writing it? Because he doesn't want to, he's lazy. Y is greater than or equal to 0. What if the arrow went downwards? Then it would be less than or equal to 0. Everybody understand? Everybody got it? Yeah? Yeah? All right. Okay. Your job for tonight, well, for the last 10 minutes of class, last 15 minutes of class, is page 148. You've got the answers there. 148, 149, and 150 and 151 are what we're going to start on tomorrow. That's what we're going to open with. So you do 148, 149 tonight. Normally I would have assigned 150 and 151, but you have a test tomorrow, so I'm going to allow you to study tonight. Okay? Everybody good? All right.